Okay, I thought we'd have a look at some of the comets that we've seen over the last 2 years that various people have photographed. I thought there were about four, but David's done another one very recently, which brings it to about five, I think. Before we go on to that, I had a look. There's some chart here of various comets, the recent comets in 2025, plus some in 2026, and I think some of the ones seen by members of our group have been, or photographed by members of our group, the R2 Swan comet, that one, the K1 Atlas. David took an image of that one. The A6 Lemon comet, quite a few people have taken photos of. And then the other ones are really in the future, really in 2020, late 2025 or 2026. This one caught my eye a little bit because it appears to be available for quite a long time. The green area is visible in the northern hemisphere. It's C 2024 E1. I don't know how you pronounce it. It looks like Virtuos. But it's actually quite a faint comet, I think, having looked it up. So we'll just have to see about that one, really. One of the things I wanted to have a look at was when you got the comets moving against the fixed stars in the night sky. I wanted to have an idea about what was happening and how fast they'd been moving. So it's just a tiny bit of background information here. On the left-hand side, I've got a brief calculation about for long period comets, about the orbital speed of a comet. And we've got a basic formula here, which has been changed in this area here to change it to astronomical units. So the speed of the comet around the sun is 42 divided by square root of r kilometers per second. So if r was one, it would be about 42 kilometers a second. So the main reason I put this up is that as the distance from the sun increases, you can see it's going to slow down, and as r gets smaller nearer to the sun, it's going to speed up. And then the same idea over here for short period comets. In 1618, Kepler came up with three laws for planetary or cometary motion around massive bodies like the sun. And his second law was that if you join a line from the sun to this is for an elliptical orbit, from the center for the sun to the actual perimeter of the orbit, that equal areas would be swept out in the same time. So you can see, because it's a long way across this way, and it's a relatively short distance from the sun in this direction here, as the comet goes around the sun, in order to keep those two areas the same, it has to be going faster as it goes around the sun. I think it actually has not just the fastest speed in its orbit as it goes around the sun, but it's also the maximum acceleration. I started to have a look at some of the properties of comets, and I don't want to spend too much time on this one really, but there's one or two things that came out of this. For a very short period comet, the Pons-Brooks comet, the 12P Pons-Brooks comet, which was in early 2024, is a short period comet with an orbital period of about 71 years. Almost all the other comets are long period comets that we've looked at. I think all of them are. And there's one or two characteristics here that are interesting. The R2 C2025 R2 Swan comet, this column here is the inclination to the ecliptic. And you can see that the Swan comet is very, very close to the ecliptic. It's actually orbiting almost in the ecliptic here. And I'll put a few dates down here for the dates where they reached perihelion. And most of them, I think, were after perihelion when we photographed them. There was one that wasn't, I think possibly maybe this one. Yeah, I think maybe the A6 Lemon was approaching perihelion when various photographs were taken. But the one thing I wanted to show you in this chart here, or is that I had a look at the rate that comets tend to move across the night sky with respect to the fixed stars. Because obviously, if you've got a telescope that's tracking the fixed stars and the comet's moving against the fixed stars, the comet's moving against the frame of reference that you'd normally be stacking in an astrophotography photograph. And the typical rate of movement is between about 3 and, pardon me, 10 arc seconds per minute. So if you say, these two are about 10 arc seconds per minute. So if you take some photographs, a series of photographs that might last a total of a minute, then the comet's going to move about 10 arc seconds against the fixed stars. So give you an idea of how much it's going to move. This was picture taken by Nick in October 2024 of the A3, I can't pronounce this. I call it a T Atlas, T Atlas comet in 2024. And you can see in this photograph, I think he used a Sony camera of some type. I think he knows exactly which camera it is, but I haven't got that information here. But you can see in this photograph, it's in the middle of the Ophiuchus Serpens constellation within this boundary here. If you just remember where it is there roughly. Then there was another photograph taken by Ron Kelly, who I think is on Facebook. I think he's a member of the camera club in Penrith. And he took a picture using this camera here, a Fuji X-T5 camera. This is a good quality mirrorless camera but I think it's a 40 megapixel sensor in the camera, and it was just a 3-second exposure. This line here is the edge of Ophiuchus, so you can see it hasn't reached Ophiuchus yet. It was taken at a different time from the one that Nick took. And it was several days apart. We can see there's quite a big light gradient across this, and the reason for this is the comet and the tails come out quite well in this, even though it's 3 seconds, because he took this picture. I think it was from the beacon in Penrith, and I think it was looking right across the light pollution from Penrith. And there's a chart showing the movement across the night sky of the T Atlas comet in October 2024. To some extent, you can see what I was saying earlier about as the comet comes around the sun, it's going fairly quickly as it near perihelion, but as it pulls away from the sun, it's going to slow down. You can see these markers at intervals are the same number of days, but you can see it's going quite quickly here, and then starting to slow down as it goes, even as it goes away from the sun. There might be a bit of a perspective impact here as well. I'm not sure, but it does show the movement of the comet like that. And you can see Ophiuchus is here. So these photographs must have been taken round about this time on the dates there. And that was another one of the T Atlas comet by Nick with a sea star again in October 2024. I thought that one came out reasonably well. Has anyone got any questions? We can obviously stop at intervals if we want to discuss anything. This is the C2025 A6 Lemon comet, and David took some pictures of this. This was with the Dwarf 3 smart telescope, and that's about 20 minutes, isn't it? You know what I was saying earlier about the movement of a comet? If it's about 10 arc seconds a minute, we've got 20 minutes total integration time here. So in 20 minutes, the comet could easily move 200 arc seconds. What's that? It's more than 3 arc minutes. And you can see the nucleus of the comet here has gone into a line because of that extended period of time. In order to get the exposure, he's managed to get the tail like this, but of course the nucleus has smeared out into a line like this because of the extended time for the exposure as the comet moves against the background of the fixed stars. So obviously we'd like to eliminate that, and David has had a go at that, I think, with another picture of this comet. This is a very common problem with comets. It happens a lot. I think if a comet is bright enough, it may be possible to take a picture in a short enough time that this particular type of situation doesn't occur very easily. And that happened with one of the brighter comets that we had in this series. But I'll move on to the next picture.
Julian, can we just pause there just for a minute?
Yeah.
I think I've mentioned a chap before, and I think one or two of you might have looked him up, called Adam Block,
Yes.
and he's come up with a fantastic way of processing comets. And what he does is similar to what we've done with other images that we've done by separating the stars, but then each frame of the comet then you basically you put a gratiscule on the nucleus of the comet and stack from the nucleus of the comet.
Yeah. Yeah.
So
We,
so
we,
does that make sense? Yeah.
yes, I appreciate what you're saying. Yes, I think that can be done both in, well, I'm aware that it can be done in Cyril and it can be done in PixInsight as well.
Yeah. Yeah.
Um,
Is that what David's done? Do you know anything?
yeah, well, we're just coming on to that.
Oh, sorry.
Yeah, it's all right. So this is probably the best picture I think anybody's managed to take so far of a comet. David did this one. It's about 17 minutes in total, and he's done exactly what you were describing, Tony. But he's done it in Cyril and using the Dwarf 3 telescope to photograph it. And you can see quite a lot of detail in the tail of the comet here.
Yeah.
Um, I'm not really sure here whether I thought this was probably the dust tail here, and outside of it might be the iron tail. I think the dust tail is probably these streaks here, I think. Do you think that could be the iron tail? I think it's the beginning of the the dust tail and the iron tail diverge a long way away
Yeah.
from behind the comet usually. So I think that's come out pretty well, really. It's got a lot of detail in it, this one.
Yeah. It's nice, isn't it?
I think one of the tricky things about the kind of processing you were describing, Tony, is that when we'll come on to it in a minute in a bit more detail, but you see you stack the initial um, subframes and register them on the stars, and then you can use some of the registered images to stack the comet using the starting position of the comet and the end position of the comet in the sequence of subframes. But then, of course, you have to remove the comet from the stacked images of the stars and also remove the stars from the stacked image of the comet. And one of the problems that seems to arise is that when the comet image is stacked, the stars instead of being point dots like this, obviously the stars will be moving and the comet is being stacked on top of each other. So you're trying to keep the comet in the same place. So when you come to try to remove the stars, you're trying to remove not dots of light, but little streaks of light from the stars. And that seems to be a common problem on how to remove them without leaving any trace of them behind. So David's done a pretty good job on this particular. I think this is the best photograph so far, to be honest. This is another picture of the same comet that I took with the sea star, and these are 1 minute exposures, but they're taken 23 minutes apart. And if you have a look at the photos, it's, can you see the mouse can you really see the mouse moving here?
Yep.
Yeah.
That star there is the same star as that one there. So the width of this picture is about 0.7 of a degree for the field of view from across this way, 0.7 of a degree, which is about, was that 42 arc seconds? 42 arc minutes, sorry. So you can measure how by using a star like this, you can get an idea and measure on the photograph how far the comet has moved in 23 minutes to get an idea of how fast it's moving across the night sky. I think some of the tail has come out here. You can see some details in the tail, but obviously this is only 1 minute, whereas David's pictures that he was taking was about 20 minutes of data. So you've got a lot more detail in his picture in the tail of that's the same comet.
I think frame for frame, if I'm honest, is if you'd have replicated that, and done a little bit more time, it would have been quite as much. There would have been as much detail, I think, would there? Oh, sorry,
Yeah.
you've done 23 minutes there. Oh,
You
23
see,
minutes
I haven't
apart.
done I haven't done any
Yeah,
sophisticated processing on this. This is just a one
yeah.
minute.
It's
Uh,
sharp enough, isn't it? It's quite as good as that.
it just happened to be bright enough, and not. It's only moving about 10 arc seconds in that time, which is why you can see some detail in the tail.
Were there a moon around that time of the month as well?
Uh, I'm not sure. I can't. I could look it up.
22nd. Probably, they probably were, weren't they? Yeah. Yeah, it's good as that,
I
really.
could get a book off the bookshelf and look up what the moon was, but
No, it's
I'm not
just
sure it's
interesting
worth it
because it
really.
looks nice and dark and sharp, doesn't it?
Well, I was pleased with that anyway.
Yeah, no, I'm not surprised. It's good.
But it's interesting, even in 20 minutes, you can see how it's moved.
Yeah,
I mean, what's interesting is that Stuart Atkinson, yeah, he did 3 or 4 hours worth over one night and then repeated it over 3 days of that comet. And he's produced a little video, and you can see how the material is moving up and down the tail, and then
Oh,
also
all right.
how it's tracking across the sky. I mean, I know we've got him coming, a couple of weeks' time. I might ask him if he can bring that information so he can show you guys that. But it's really a very nice video.
Yeah, that would be very interesting. Yes.
Yeah, yeah,
Was it this particular comet? Was it?
yeah. It was that comet again using the S50.
All right.
Yeah,
Okay.
yeah.
And I had a go at the C 2025 R2 Swan comet, but it didn't come out terribly well. Um, that was just a 1 minute exposure. I think that was the same. It was the same date as the previous picture. But you can see the definite greenish color to this particular comet. If a comet has got a very bright green color, it's usually due to carbon compounds in the comet, different types of carbon, maybe diatomic carbon, or there's another compound. I think it's cyanogen, and various other carbon compounds produce the greenish color like that. I did collect a bit more data, but it just got in a bit of a tangle, really. A bit like that, really. The comet hasn't broken apart here. That was just my gap in the photography. I think the tail was actually out this direction. I did have a go at processing this a bit more in PixInsight, but it just wasn't enough data, really. I think it's really a bit small, this one. I had a look I've got a book that was published about 7 or 8 years ago about astrophotography, so it's a bit out of date now, but they had some other ideas. Some people in the past have tracked a comet with a programmable RA deck rates, where you're tracking on the comet and you're not bothered about the stars. You don't bother about this. You just let the stars do star trailing and tracking on the comet by programming the speed of the mount. And the other idea they came up with is to auto guide on the comet nucleus if it's bright and compact enough. I've no idea if that's feasible at all, but that's one of their suggestions anyway. What do you think about that, Tony? Do you think that would be realistic, or that you've done a lot of auto guiding?
I've never tried it on a Comet, to be honest.
But do you think
It
that
has its
idea?
challenges. It has its own challenges on long focal lengths, to be fair.
But do you think that idea would actually work, auto
It could
guiding
work
on the
because
comet?
you can choose. I suppose it's only like selecting a star to guide on. Like you said, if it's bright enough, I can't see any reason why you can't select the comet. It'd be interesting to try.
Well, if it's a small bright nucleus, it might work, mightn't it?
Yeah, but then it's a personal thing. A shot like that doesn't do a great deal for me. I'd rather have that processing, with the stars, stacking the stars separate to the comet nucleus.
Yeah,
Um,
it's just another idea, really.
yeah, yeah,
May I say something?
Yeah.
yeah.
Um,
Well,
I've seen lots of comet photographs, but only two really stick out. One was one of Comet Holmes, and it sticks out because I took it. It was about my most successful fluke of a comet I ever took. The second one was similar to this, but there's a lot more zoomed in, and the stars were a lot more trailed, but they were started off as white. There's a gap, and it turned to blue. There's a gap, red, and a gap. Thing. Obviously, they've done this, but the gaps is a way of changing the filters, and that's why that one stood out for me.
Mm.
What equipment did you use to take the picture of the comet then? Was it a camera or a telescope?
Oh, it was a camera. This is going back years.
Right.
you see,
I think it was I forget where I saw it now. Might have been in the Sky at Night magazine. I can't remember. So long ago.
Okay.
would you get a similar effect to that if we talk about stacking, and obviously more often than not we stack the stars, don't we, to get a nice sharp star and an image, but you can actually stack the frames, so um a similar image if you just stacked the frames rather than the stars, wouldn't you? And
I
I
didn't
don't.
guess.
crop. In other words, you wouldn't be cropping it, would you? You'd just be stacking the um, perimeter of the frame. You get that similar situation, wouldn't you?
I think so.
It's interesting.
Uh,
Problem is, we don't get enough of these things to really have a good
well,
experiment, do we?
this is what David said he'd done in Cyril. That
All
was
right,
his
yeah.
his workflow, and he took this picture of the C 2025 K1 Atlas comet, and that's fairly recently. But he did say he had trouble removing the stars, and
Oh,
so the
yeah,
comet has been stacked on, using this procedure here. But you can see it's been problematic getting rid of the streaks from the stars. You can see them
yeah,
slightly in the background here.
yeah.
So you've got to stack normally and then create a star mask, to remove the stars from all the subs of the register's lights, to re-register the starless registered lights with the comet mode, selecting the comet in the first and last images of sequence. That's stacking the comet, isn't it?
Mhm.
That part there.
Yeah, yeah.
And apply the registration, stack it, and mask the stars back in. So basically, you're stacking the stars to start with, take the comet out, then stack the comet and take the stars out, and then put it all back together again.
Yeah,
I
Yeah.
think that's basically it, isn't it?
that's it in a nutshell, I think, Julian. Yeah.
So that's what he was using in Cyril. Now, there are some tutorials in Cyril. I haven't looked at them, but there's clearly a lot of information in Cyril about stacking using that particular type of software. So there's plenty of information in Cyril about this. There's a whole series of tutorial chapters about this. So that's one way to find out more information about this. And then the general procedure that we just looked at, that David was using in Cyril, there's the same kind of thing is available in PixInsight. And there's a YouTube video by, I think the YouTube channel is called Visible Dark, and I've got the link here. This video, I found it to be an extremely interesting video. It goes through step by step how to do this process in PixInsight. So it's the same type of structure as what we were looking at in Cyril just now, but it's the PixInsight version of it, as it were. So he explains in great detail how to do this in PixInsight. I did have a go at this for one of the comets, but I haven't quite finished that yet. And I thought that was quite a good video, that particular one.
Has anybody used Deep Sky Stacker?
Not for a while.
You can do it in that as well.
Well, yes, there's probably lots of ways of doing it. These are just the
Yeah.
ones I thought
Yeah.
most people had used, but there's probably other ways to do it.
Yeah, they're interesting.
I think this chap on YouTube, he borrowed the data from a friend of his who took the comet picture somewhere else in another part of the world.
Yeah,
I think that's what you were talking about, isn't it, Tony?
yeah, yeah.
There's some courses by Adam Block.
That's him.
I presume that's for PixInsight, like a more comprehensive
Yes,
type of
predominantly,
course.
yes, it is. Yeah.
That's the end of the presentation at the moment.